Hi, we're going to keep going. And now we're going to work on proportion tests. So this is the number 2 in the practice problems for chapter 9. So let's look at it. Your statistics instructor claims that 60% of the students that take her elementary stats class go through life feeling more enriched. For some reason she can't figure it out, most people don't believe her. You decide to check this out on your own. You randomly survey 64 of the past elementary statistics students and find that 33 feel more enriched in the results of their class. Now, what do you think? Conduct a hypothesis test at the 5% level. All right. There's nothing in here about means, nothing about standard deviations, and you have percentages. So that means this is a proportion test. So let's talk about those hypotheses. Okay, so we're going to look at this, and she claims 60% feel enriched. So which one would I pick, though? But she's finding out that most people don't believe her. Okay, so that would mean that let's look at these things that it could be. So one way that you want to do it is you want to think about what we're going to test. So it's finding out that it's lower. So I would start down here and do this as a less than problem, okay? Because it's showing that it's less than that. The reason I can't do it in the null is because she believes 60% believe that. So she believes 60% or more are enriched in her class, so it would be that one. I know this one's a little bit confusing, but you have to think about it as where she said here she can't figure it out, people don't believe her. So they're saying that's not that high. So that's where I get these hypotheses. Okay, the next thing I want to do is I want to figure out my the random variable, and we write it as P with the apostrophe on this one. So for this one, we want to figure out the percentage of students who feel more enriched for taking the class because this is a percentage question. So I want to say people who feel more enriched as a result of taking elementary statistics or students who didn't feel. Because I don't need to worry about the other ones because I don't need the ratio, I don't need the number, I need this one. I need the percentage that feel more enriched. So what's the distribution for this test? It's actually a z-test. So that's all you have to put in there. So to get the test statistic. All right, so let's go ahead and go to the calculator. All right, I'll turn it on again. So now I'm going to go to stat. I'm going to go over to test, and I'm going to go down to number 5. So one proportion z-test, that's what I'm going to use. Now, if you go back and look at part D, I have a z in there, so that would make sense. All right, so for the first one I need to do the PO, and what that is that's the percentage that was in my hypotheses. Oops, can't do that one. Hold on. Sorry. It's 0.60. Remember, that is the proportion that was in my hypotheses. Okay, X is the number of students who answered. Let's go back up to the problem and I'll show you. Okay, oops, not that problem. This problem. So she finds 33%, 33 of them feel more enriched in the class. That's where I'm getting that 33 from. N is for everybody in the class that was surveyed. So if I go down, that's 64. Okay, I also need to go to my alternative again and make sure and see my alternative was less than. So I'm going to put that in there. So this is going to be a less than down here, and then I hit calculate. All right, so I have my Z and my P. My Z is negative 1.3778. I'm going to go down here and see how many decimals it needs. It needs 3. So I'm going to put a Z here, and I'm going to put negative 1.3. And let me make sure I've got my decimals right before I start. 378. So that's going to be my answer, 378. And then I need to put my p-value. So I go here, put my p-value. What's my p-value? So my p-value, they want 6 places, so it's 0.5156. Now, where did I get that? The calculator gave me, the calculator gave me everything I needed right here, Z and P. And another check is look right here. You can see your alternative hypotheses, and there's your N. All right, so what am I expecting that p-value to mean in this problem? So if I keep looking at it, so if the null is true, there's a chance, okay, remember my null that it was equal to or greater than, there's a chance that the sample ratio is 33 out of the 64 or less. So that's what I'm going to put. Okay. Right, and we keep going down. So for this one, sketch it. Remember this was a less than because the alternative has a less than. I'm going to put that as my answer because it's a less than at the left tails. And then for here, I've got to put my level of rejection. Oops, sorry, for right here, which is 0.05, and I got that from the problem. So is 0.5156 less than or equal to the alpha? It is not less than or equal to the alpha, so I do not reject my null hypothesis. Okay, since alpha was smaller than the p-value, what do? We don't reject the null. Let me say that again. Since alpha was smaller than the p-dot value, we do not reject the null. Okay, so what is the significant evidence? Okay, so let's see. I'm going to go up here again and look at my alternative. My alternative was p was less than 0.6, and we found that it wasn't true. So there's not sufficient evidence to support it. That's how we work those problems. So if you get confused, just look and see what I did, and hopefully it will help you with what's going on with these, okay?